In a previous video, we talked about the algebra functions, and with that, we talked about the operations functions, how we could apply different operations to create new ones that could potentially change the domain and range of the function. All right. So, and with that, we talked about the basic, the basic four operations: multiplication, addition, subtraction, division. But I also mentioned a composition of functions. And so that's what we're going to talk about today. So let's hop right into it. So what is a composition? So with operations, all right, I want you guys to think of a box in a real world example. All right. So imagine this box. All right. Let's make that more 3D. Look like I'm horrible at drawing, guys. Sorry about that. All right. So we have a box. And within this box, there's a bunch of balls. Alright, with the balls, alright, so we could say those balls are composed inside the box. Alright, so in other words, the balls are inside the box. So in a mathematical sense, alright, to compose a function, we put a function inside of another function. And we simplify it down, and it creates a new function, changing the domain and range. Alright, so writing it in a more mathematical sense, alright. Alright, so let H be defined. Alright, so let's start down here. Sorry, my notes are a little messy. But so let H be defined as the result of a composition. Alright, and let F and G be functions with respect to X. Alright, so we defined FOG, F composed of G, which is written as FOG, or GOF. G composed G's F composed in a G, G composed in F. All right, is written as F of G of X, which is FOG, and GOF is written as G of F of X, which is written down here. All right. So whenever we plug in a function into another function, we get a third function, and we define that function as H. All right. So the first case, H of X is equal to the composition of G inside of F, FOG, or in simpler terms, H of X, the function H with respect to X is pretty much F with G plugged into it, and in the second case we have H of X is equal to GOF, or pretty much we're composing F inside of G. We're putting F inside of G. So we're putting F inside the box. H of X. So H of X is pretty much is G is G of F of X. So we're plugging F of X into G. All right. So let's do a couple examples really using this. Sorry for the stuttering and the tiredness. Actually, this is like my fourth or fifth take doing this video. So, all right. So let's do the first example. All right. So, a common test question will be like find FOG. If all right. So let's start. So the problem starts here. All right. If f of x is equal to 3x plus 2, g of x is equal to 3x squared plus 2. All right. So, by definition, FOG of X, FOG is defined as the composition with G of X plugged in F of X, so F of G of X. So, we take our F of X function, which is 3x plus 2, and we're going to plug this whole value into G of X, which we showed here. So, it'll be 3 times the function, G of X, 3 times, so we plug this in for the value of X in this case. So we plug G of X into X. So the easiest way to show this would be it'll be 3 times G of X plus 2. Okay. And pretty much what's going on here is we're just simplifying it down. So to distribute, we get 9x squared. 9x squared plus 6 plus 2. That's the basic distributive property. And we also have, and clean it up even more, we have 9x squared plus 8. Simple. Now we have the GO, and now I took a step further. Let's do GOF. Alright, same case. Alright, in this case, but it goes, so GOF, or trying to find the composition with F going inside of G. We say, okay, we're going to plug in the value of F inside of F or G. So pretty much we're going to write it out as 3 times F of X squared plus 2. So that's G of X with an F of X put into it. Alright, so which comes out to be 3x squared, 3x plus 2 squared, 3 times 3x plus 2 squared, plus 2, simplified down even further, that's 3 times 9x squared plus 12x plus 4, plus 2. Alright, so distributing even further, we get 27, so expanding the binomial, this binomial, we get this, and we get 27x squared plus 36x plus 12 plus 2, and clean it up one last time, we get 27x squared plus 36 plus 14. So as you guys see is, every time we compose a function, it completely changes the functions in general. Now what happens if we get, so now we could always do this an infinite number of times, and we could actually change the domain. And it happens quite a bit. It changes the whole behavior of the function, like adding a ln to sin x, or adding an x squared into an x cubed makes it an x to 8th, so it makes an even function instead. Well, we can do that an infinite number of times to get new functions, and it's actually pretty helpful, because it allows us to explore more into mathematics than we possibly could. Alright, so now, alright, so what if we have 3 or more? So, alright, so what if we start to create a chain? Alright, so this chain right here, alright, so we could add more and more functions. We could compose multiple functions, and we just take it one step at a time. So another common test example would see is compose. F of x, f of x is equal to x. G of x is equal to 3x plus 4x squared plus 2, and h of x is equal to 1 over x. All right, so pretty much, in other words, find f o g o h. So meaning, all right, so similar to the original definition, we say, okay, it's f of g of x, f of g with h plugged into it. So we plug in h of x into g of x. We plug the g with h in it into f. So that's 2 layers of the chain. It creates a chain. If you think about it, it creates a chain link. Sorry guys, it creates a whole chain link in it. We're just putting things. It's like putting it's like putting a box inside of a box inside of a box inside of a box, or the Chinese nesting dolls, where one piece of the doll will get smaller, and the other piece of the doll will get smaller and smaller and smaller and smaller. Eventually, it'll get really tiny. Well, and each of those tiny nesting dolls represents a function. Alright, so doing this example, okay, so we're going to take it one step at a time. So, alright, so we defined f of x is equal to x, g of x is equal to 3x squared plus 4x squared plus 2. I know that's not in standard form, and h of x is equal to 1 over x. Once again, sorry for the mess here, we're just going to do this quickly. Okay, so pretty much what we're going to do here is we're going to, okay, so let's readjust that. Okay, so we take it one step at a time. So let's focus on the h going to g first. All right. So don't try to go completely gung ho. Just take it one step at a time to really get what's going on. That's the cases for a lot of math problems. All right. So we're gonna plug in h of x into each value of f. All right. So GOF of x. GOH, sorry, of x is equal to, so we're going to put 3 times 1 over x, oops, sorry, actually it's 3 times h of x plus, oops, sorry, 4 times 1 over x squared plus 2. Okay, so, or h of x, sorry. Sorry for the, so pretty much what we're going to do is we're going to put h of x into each value of x for the g of x. Alright, and shortcut, so to shortcut it, honestly, once you actually could see that, I normally, in my proofs, I usually don't write this out as much anymore. Once you get the proficient skill. But so now it's 3 times 1 over x plus 4 times 1 over x squared plus 2. Okay, so simplifying this, we're going to simplify this down real quick. Alright, so this is 3 times 1 over x, which is 3 over x. Alright, multiplying fractions. Alright, so plus 4 times 1 over x plus 1 over x plus 2. Okay, so dealing with this, alright, so 4 times 1 over x, that's times, sorry, times 1 over x. So we have, so this creates a 1 in the numerator and x squared in the denominator, times 4, so it'll be 4 over x squared. So we have 3 over x plus 4 over x squared plus 2. And we plug this all into f. So f of x is equal to x. Then, oops, sorry guys, you guys can't see that. F of x is equal to, so then f of g oh is equal to GOH of x in this case. Okay, in this case, all right. So we're just going to plug into this. All right, so to compose it completely, we plug this function value into x. So f of GOH is equal to 3 over x plus 4 over x squared plus 2. So that's our final answer in this case. Because, alright, so you guys might be confused. Why did that happen? Well, so if we look back at the definition, alright, so this since we composed our h of x, alright, we plug it in, so our GOH, we plug that back into f, because h goes into g first, and then that composition, that result, gets plugged into f. Alright, so with that being said, I'll see, our time is pretty much up. We'll see you guys next video.